All right, we're taking a look at lesson 7.1.2, how can I find the rate? And we're going to compare rates today, but we're going to focus on the graphs, not the tables. It says rates are used in many situations to describe and compare information. When purchasing a car, you might compare the gas mileage of the vehicle. That is, how many miles each car can travel per gallon of gas. When determining the print quality of a printer, the number of dots per square inch is important. The percent of interest earned per dollar or interest rate is important when saving money in a bank. So we're going to go down to problem 715, training for the triathlon. A triathlon is a race where participants swim, bike, and run specific distances. Participants start by swimming, then jump out of the water, get dressed as fast as they can, and ride a bicycle. After they complete the biking section, the participants finish the race by running several miles. Diane has been taking swimming lessons, riding her bike, and running to prepare for this first triathlon. She used the graph at the right to analyze one of her practice sessions. Using the graph, so you can go back and get the resource page at the very end of this lesson, but I think we'll be okay with this graph. A says, during which segment of the race, A, B, or C, did Diane go the fastest? So let's look at the lines. So where did she travel the farthest amount in the shortest amount of time? I'm hoping you're saying that B is the segment that she traveled the fastest and in the shortest amount of time. Okay? B says, using the graph determine the distance traveled during each segment of the race. So now we're going to be investigating this graph. Okay, so right here, letter A, looks like it took her, so we have to figure out what the graph's counting in, 12, it's counting in sixes, so like the 6 here at the beginning is missing, and so this would be 18, okay, so this dot is at 18, and it's not quite at 1 over here. I'm going to blow this up a little bit more. Okay, so if this is 1, I'm going to say that this is a half. Okay, so in section A, she went a half mile in 18 minutes. Section B. This is where it can become a little tricky if we're not careful. So section B didn't start until 18 minutes. Okay, and it looks like it's at 60. Okay, so it went from 18 to 60. So the time was 60 minus 18. And the distance she traveled looks like 12 and a half up there. So remember, she went a half at the beginning, so 12 and a half minus that half is going to mean that she went 12 miles. And her time was 42, right? Okay. Back over here to B. She went 12 miles in 42 minutes. Okay, now let's look at section C. I'm just going to choose a different color. do blue. Okay, so remember section C started at 60 minutes. It looks like it goes to 96. So the time here was 96 minus 60. I can't fit it on here. 36. Okay, so she traveled for 36 minutes running. And how far did she run? Remember, A was the swimming, B was the biking, and C is the running. So it looks like if she started here at 12 and a half, and she went up to, did she go up to 16? Yeah, say she went up to 16. So the distance here she traveled up would be, maybe it's not 16. I think it's 15 and a half. So she went from 12 and a half to 15 and a half. 3 miles. 3 miles in 36 minutes. How much time did it take Diane to complete each segment? Oh, well, we did that in the same problem. So B said use the graph to determine the distance, and C said find the time. So we kind of did that in B, so I'm just going to draw an arrow. I'm not rewriting it. D says write a rate in miles per minute for the segments of the race. So we're going to be writing a fraction for these, and it's going to be miles over minutes for each section. So we're writing a fraction. So for A, 1/2 mile for every 18 minutes. So 0.5 for every 18 minutes. B was 12 miles in 42 minutes, and C was 3 miles in 36 minutes. How can you show a rate on the graph? Work with your team to find a way to show the rates from part D on your resource page. So if you did kind of what I did, that's how you find the rate. So if you look specifically at B, you can see that I drew that line straight up. And so if I drew a line straight over, that makes a triangle, okay? So when we find the rate, so from 18 to 60, so from this point to this point, we know that that was 42. And then from this point to this top point here, we know that that was 12. So the length of the triangle and the height of the triangle is where you get that rate from, the fractional rate. So that fractional rate is called a slope. That's how steep your line is. And we always write it as the rise, so the 12, over the run. Okay, so down here to E, how can you show the rate on the graph? By making a slope triangle. Okay, you have some problems to look at on your own. I hope this made sense.